In this video I will show how to solve question 2 from the re-exam of 2016, in which we will analyze a reactor settler system used for the treatment of wastewater. We will follow the 3 steps of coding, starting with step 1, defining our problem. We are given that the system can be defined by 4 equations: the substrate, oxygen and biomass balances over the reactor, and the biomass balance over the settler. A substrate or oxygen balance over the settler would not add any extra information, since the concentrations do not change. In this system we have 4 unknowns: the substrate concentration in the reactor, Cs, the oxygen concentration in the reactor, Co, the biomass concentration in the recycle stream, Cxr, and the sludge retention time, SRT. All the other parameters are known. Thus we have 4 unknowns and 4 equations. Our task is to find these 4 unknowns. To find these unknowns, we will first separate the knowns on the right-hand side of the equation. So all the unknowns are on the left-hand side. We can rewrite this in matrix notation by separating the unknowns in the x vector. We can check the rank of matrix A to see whether the equations are independent. So let's start out by writing out the parameters. I will name the parameter b decay, so we can use b for a vector later on. Now we can write up matrix A and check the rank. The rank of our matrix is 4. Thus we have a determined system. Notice that I've used 1 over SRT as an unknown instead of SRT. This is so that we still have a linear system. Afterwards we can simply calculate SRT from the value MATLAB will give us for 1 over SRT. Now we can implement this in MATLAB. We can now write out our vector b and solve the system by calculating a over b. Now we should remember that we were solving for 1 over SRT. Thus to find SRT we need to calculate 1 over x4. This gives us the answer. However, the answer gives us a negative oxygen concentration. I've made a typo. So always ask yourself whether the outcome is possible and logical. Question 2.2 asks us to vary the Q in between 100 and 200 cubic meter per day. How shall we do this? Remember, we can use a for loop. We will do the previous calculation for a range of Q in values. Therefore, we will need to make a vector of Q in values and loop over these values. We want to plot the value of SRT as a function of Q in. Thus we need to store the value of SRT within the loop. Using this notation, the next value of SRT will be placed in a row vector next to the previously calculated values. So in the first loop, Q1 is 100. Since the SRT vector is empty, the SRT value calculated for the first Q in value will be stored in the first column of vector SRT. In the second loop, Q in is 101. The calculated SRT value will be placed in the second column of the vector. This way the SRT vector will store all the values from the loop. Now we can plot the vector of Q in values to the vector of SRT values. So let's try all of this in MATLAB. Let's first define our range of Q in values as the vector Q in V. We want to loop over the vector Q in V, and we want to store our SRT values by making a vector of SRT. Don't forget to define this vector beforehand. We can use the debug mode to check whether the SRT values are stored indeed. In the first loop, the first SRT value is stored. In the next loop, the second SRT value is stored in the second column, and so on until loop 101. We can now plot the Q in vector against SRT, which gives us this figure.